Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and today I've been asked for some help with this circle equation question by one of my GE on their way to start their Maths A-level. There will be a chance to look at this in a bit more detail next year, but just to briefly go through this question, let's begin. A circle has the equation x squared plus y squared equals 5 right down the centre of the circle. Okay. Just to catch you up with the vague idea here, the general form for a circle equation is x minus a squared plus y minus b squared equals r squared, okay? It's basically a version of Pythagoras' theorem applied to the points around the centre of a circle, where the centre, the middle coordinate of the circle, is a, B, and where the radius, the length between the middle of the circle and the outer edge, is r. Okay? Now, what that means, really, is for this particular question, x squared and y squared are just on their own. You can think of this as x minus 0 squared plus y minus 0 squared. Basically, the centre is therefore 0, 0. Okay? And r squared in this particular case is 5. Okay, just bear with me. So if r squared in this circle form is 5, then the exact length of the radius of the circle, which is what the next part is asking us for, is the isolation of r, where r squared equals 5. Or in other words, the radius is the square root of 5. Okay, and this stuff comes with more practice and more detail given during the Deps year, the kind of first year of A-level next year. P, part C, P is the point 1, 2 on the circle, the circ, x squared plus y squared equals 5. Work out the equation of the tangent to the circle at P. All right, let's do a vague representation of what's going on. It's a circle. The centre of the circle is the origin of an xy graph, okay? And the radius, the length, is the square root of 5. So that will be ranging between positive and negative root 5 on the x and on the y, okay? Just a little sketch here representing the circle that we've got. Now the point 1, 2, probably somewhere like up here. It doesn't have to be perfect, but yeah, we're looking for the equation of the tangent. In other words, the straight line that touches the circle at that one point. Okay? Now, one thing that you might remember from GCSE maths is that the radius of a circle always meets the tangent of the circle at 90 degrees. Now that's really useful. That actually enables us to work out the equation of this tangent. If I can work out the gradient of this radius, then I can use the perpendicular gradient to work out the equation of that tangent. And because I know that point there is 1, 2, knowing the perpendicular gradient would be enough for me to work out, enough information for me to work out what the equation is. So we know the centre of the circle is 0, 0. We know that this edge point of the circle is 1, 2. So we can work out the gradient of the radius, can't we? It's the change in y over the change in x. Now, what's happening between the y values here? They're going up by 2. What's happening with the x values here is going from 0 to 1. So that means that the radius gradient is 2. This gradient is 2. What is the perpendicular gradient therefore going to be for this mysterious tangent line? Well, if you remember what we talked about in our revision class, the perpendicular gradient is the negative reciprocal. In other words, flip 2 around to become a half and make it negative. Negative a half is therefore going to be the gradient of this tangent line. Now, if you were following what I was talking about with our new straight line equation form, we could definitely use y equals mx plus c here. That's no lie. We could definitely use that. But we could also use the new form A-level form, which, if you remember, is y minus y1 equals m times x minus x1, where y1 and x1 here are the values of the coordinate that we have on the line. In this case, 1, 2. So we actually know everything that we need here, including the perpendicular gradient and including the coordinate that we have, to substitute into this general form. It becomes y minus 2, because the y part of this coordinate is 2, equals minus a half times x minus 1, and 1 being the second coordinate, the x part of the coordinate here. Okay? And the rest is just, well, this is an acceptable answer for the question, but we might as well do some rearranging here. Let's times both sides by 2, so get rid of that half. 2y minus 4 equals minus x plus 1. Why not at the same time expand that fraction out? Now, if I add 4 to both sides and add x to both sides, I end up with a form which is fairly presentable. 2y plus x equals 5. Okay, I achieved that by adding 4 to both sides, cancelling that out, and adding x to both sides, which cancelled that negative x out. Okay, so 2y plus x equals 5 is a perfectly acceptable form for the tangent here, using the gradient of the radius and finding the negative reciprocal to find the perpendicular gradient. And then you can either choose to substitute that along with this coordinate into y equals mx plus c, that's perfectly acceptable, or you can do as I've done here and use the new A-level form that we've been going through in the last couple of revision lessons. Okay? Now, I hope that makes sense. A brief overview of the general form of circle equations, how to find the radius from it, and how to find tangents. Remember, sketching always makes things easier. Once it's down, once there's a visual representation, things get a lot easier to kind of work with. All right, I hope that helps you, and I wish you all the best for the rest of your week. Remember to work hard, and don't forget to submit your work on Teams. I will talk to you very soon.